Hi everyone, welcome to the last video for week one. We're going to take a look at a little bit more Python, this time venturing into some territory, definitely venturing into some territory that you haven't seen before. If you skipped the first lesson entirely, the Python basics one, because you thought you knew everything that was in it, that's fine, but just double check that in the video starting at about 21.5 minutes, I start talking about functions, and there might be some new stuff in there, and it's everything that I say in that section is important, so make sure that you take a quick look at it at least. So we're going to take a look at functions, not functions, lists, dictionaries, and sets. You may have seen lists before. You've definitely seen dictionaries in other languages by other names. Sets might be kind of new, but it's basically the same thing as a dictionary. All right, so let's take a look at, in the Python review handout, excuse me, if you scroll down a little bit, you get to lists. Okay, so this is just a rundown. It's a basic cheat sheet of all the basic stuff that you might want to do with lists. Lists in Python are objects. They are array-like, but they're called lists because you can grow and shrink them. They can start empty, and then you can add to them and delete from them, and so on. So they're more like they're a bit more like JavaScript arrays maybe, but really they're like the lists that you would have seen in your data structures and algorithms class. They just have some special support built into the language for them. Python is kind of unusual in that it does not have an array variable type. It only has this list type. All right, I'm just starting up Paizo here. I'm going to save this file I will make the videos from these two videos available. Sorry, the examples from these two videos available. I'm going to call it lists, etc. Okay, and here we go. So to create a list is pretty straightforward. You can create an empty list like that. If you ask for the type of X, it's a list. You can also create a list that already has some stuff in it. No need to worry about types. You can mix and match types all you want. You can even have a list within a list. So if we take a look at this in the shell, this is what we get. You can index into a list using the index number starting at, oops, is that enough? No, that's too much. Starting at item 0. So this is a 7-item list, goes up to the last item itself is also a list. So when you've got lists within lists, you can do something like this. List element 6, and then that's a list, so element 0 of that list is a 2. If you try to go out of range, you're going to get an index error. Some weirdness about lists that's actually really cool, but is different. You can put negative indexes into your lists. So -1 gets you the last element of the list. -2 gets you the second last element of the list, and so on. So you can index, this list can index from 0 to 6 and from -1 all the way to -7, which would give it the first item of the list. So that's the first item of the list there. -8 would be out of bounds. So something to watch out for when you're doing your loops and stuff. Watch out for list indexing. But this is really handy. It saves you having to find the length of the list and subtract 1 from it, and so on. Basically, there's an implied list length -1, list length -2 to get you the items in the list there. If you want to know the length of a list, it's just len. Let's take a look here. I want to show you a bunch of stuff, but I want to make sure I don't miss anything. Oh yeah, a few more special operators here that I should review. One thing that Python does for you that other languages don't is that you can take a slice of a list. So I can say, give me everything from index 2 up to but not including index 6, like that. And that gets me, so 0, 1, 2, 3, 4, 5, but not including 6. So that's called the slice operator. Okay, so this is a slice. That's a comment there. I just put it in there so I could type it. You can, of course, assign to list elements like you can in most languages. You can also assign to a slice, which is really cool. So I can say I want to take that slice from 2 to 6, and I want to replace it with all zeros. 1, 2, 2, 3, 4, 5, like that. And now I've just replaced that whole slice of the list. And here's something even cooler. You can replace that slice with a smaller slice. So now all those zeros are going to get replaced with just the single -1. So you can use the slice operator to delete from lists. I can also insert. So let's put back the 4 zeros. So now, oh, oops, I made a mistake there. 2:6 gets me this part of the list, this slice of the list. So I replaced that piece with 4 zeros. So you got to watch out for that. If you, excuse me, if you want to delete, say I want to delete those zeros, that's item 2. Let's say I want to delete the first 2 zeros. So that's index 2, 3, 4. So 2 to 4, because it doesn't include 4, equals the empty list. And now I've removed 2 of those zeros from the list. So the slice operator, you might not have actually seen that in your Java course, your Python course originally, but it's really cool. That's the slice operator. You can also create a list really quickly like this. Say you want a list of 500 zeros. Just say, give me the zero list times 500, and that gives you a list with 500 zeros in it. Okay, so that's a quick way to initialize a list with a bunch of zeros or a bunch of whatever you want in it. You've also got these in and del operators. So the other way to delete from a list, 1, 2, 3, 5, is the del operator. Del x2 will delete item 2 from the list. Quick quiz, which item is going to be missing? If you said number 3, you were correct because we index from 0. So 0, 1, 2 takes out that one there. You can also do this. You can say, is 1 in x, like that. And it's true. 0 in x is false. So there's an in operator, and you can say, is 1 not in x? Oops, sorry. False is 0 not in x. That's true. So you can use that in an if statement. You can say if 1 in x, print true. Control-Shift-E to run this. Control-Shift-E to run this script. Oh, there we go. It's just a little bit slow. And it outputs true because 1 is in x. If I change that to not, the program will output nothing because it doesn't do that part of it. Okay, so that's everything in the list here. Oh, you can also concatenate lists to create a new list. So if I've got x here, I can go x plus 3, 4 gets me that list. That does not change x. So if I go x equals x plus 3, 4, then I've created a new list and concatenated x onto the end of it. That's not necessarily the most efficient way to add something to the end of a list, though. So lists in Python, they have a bunch of functions that you can operate with, but they are also objects, so they have methods too. Here's a few other functions. Sum, min, max will get you the sum of a list, the minimum and the maximum of a list. I encourage you to try those on your own. You can sort a list with sorted, and you can sort it the other way around by tagging on this keyword parameter, reverse equals true. The sorted function, so here's x. If I go sorted x, it gives me back a new list in sorted order. X has not changed. So all those functions create new things. If I say max x, I get the maximum. Sum x gives me the sum of the list. So those are a bunch of operators and functions for operating on lists. But lists, as I said, are objects, so they also have methods, which you access through the dot operator. So the more efficient way to add something onto the end of the list is to use append or extend, because it doesn't create a whole new list and then replace the variable with that list. It takes the existing object and tacks something on the end. So it's a little bit more efficient probably to do it that way. So if I go x dot append that, now x has that on the end, and x dot extend is for if you want to add more than one thing like that. That's added it onto the end. Okay, so that extends. If you do x dot append, here's a question for you. Suppose I do x dot append 3, 4, 5, 6. What's going to happen? Think about that for a second. Maybe pause the video. Try it yourself. Since append works on a single element, it's going to append that entire list as the end element of the list. So the last element in the list is 3, 4, 5, 6. Oh, I should also tell you about slices. Sorry, I'm a little bit haphazard. But you can say, give me the first 5 elements in a list like that. And then you can say, give me everything from the 5th element onward like that. So by leaving things out. You can also do this. You can say, give me the whole list, and that returns a copy of the list. You can do X. This is one of my favorite things to do. If you go like this, : 2, so basically you're saying from 0 to the end of the list, 0 to -1, give me every other element. So it's going to return, it's going to step, this is a step value. So we're creating a range here from 0 to the last element in the list, stepping by 2. You can also, you don't need to put those in. So if you don't put in a number that's going to be from the beginning to the end, and then after the second colon it's stepping by 2, and this is the funnest thing to do. Go -1 here, and it actually reverses the list for you. It gives you a copy of the list in reverse. So a bunch of little tricks there. I advise you guys to look up this stuff online and get used to some of these tricks. What else can you do? You can insert and remove from lists using methods. You can find the index of an element. This will raise an exception if that element is not in the list. So if you want to do this without raising an exception, you're better off using the in operator. Otherwise, you're going to have to use a try catch on that. Try except and counts the number of times an element appears in the list. Okay, if you want to visit everything in the list, if you want to access every item in the list, there's a few ways to do it. The for loop is built for this. So if I go for element in X, print E, that is going to print out that's going to visit all the elements in X one at a time and print them out. If that allows me to visit elements, to add them up, to print them out or whatever, but it doesn't let me change the elements. If I want to change the elements, I have to do it by index. So what you can do is you can say range length of X. That's your sort of standard construction. And then you can go print I, comma, X, I, like that. So that's what gets you the index and the item in the list. And if you want to change the list in that way, you can do X, I equals -X. Let's do -Xi. So now they're all going to become negative. And then we can repeat this down here. So the first loop prints them all out, 1, 2, 3, 4. The second loop prints them out by index and also negates them after it prints them out. Then the third loop is just a plain for loop to go and make them negative. If you want to iterate backwards through a list, you can go reversed range len X, like that. That's going to let you visit the elements in reverse order. X, I, like that. Okay, so 1, 2, 3, 4, -1, 2, 3, 4, that's this loop here, and this loop here visits them in the reverse order. And you can use the step function and so on as well if you want to go through the list that way. So that's how you would iterate through a list and visit everything in the list. Yeah, and a note on strings. If you're using strings at all, strings they're unchangeable lists of characters, so you can do a lot of the same stuff here that you could do with lists. So if I go S equals the quick brown fox, like that, for E, I'm actually not sure if this will work. I don't do a lot of this kind of thing with strings. Let's see if it does. C for character. I'm going to say print. We're going to go for each character in the string S. See what happens. Yep, it works. So this will pull it out character by character. You can use len S as well, gets you the length, and so on. So anything that makes sense to work on strings here will work. S6, but you can't change S6 to something else. Not allowed. So you can't assign to, they're immutable. If you want to do string processing, you have to do it a different way. Okay, that is lists. I'm going to pause here for a second. There are some exercises I would like you to try. Exercise 8 and 10 in particular. There's a bunch of exercise on lists. It's worth doing them because we're going to work with lists and list-like structures an awful lot in this class. So if you've got the time and you feel like you need to brush up, absolutely go and do as many of these exercises as you can. Some of the solutions to at least some of them are already posted. I urge you to try them on your own before you look at these solutions. And if there's any that don't have solutions that you want to see a solution for, let me know and I will cook one up for you. So the first one says to write a function that takes a list argument and returns a tuple of 2 items selected at random from that list. So you're going to have to use the random function. So for that you import, I covered this in the last exercise. Then you can say random.randint, say 10, like that. Oops. Randint 1, 10 gets you a random number between 1 and 10, like that. If you want to go between 0 and the length of a list, you can go 0 len string -1. So that gets me a random index into a string. Okay. Remember that you have to do the import up here, so that would go at the top of your program before anything else. So this function takes a list as an argument and returns a tuple of 2 items selected at random. So it returns value 1 and value 2. And number 10 says take a list as a parameter to a function and return a copy of the list with a random non-empty slice removed. So this gets you using slices, and it says here make it handle non-lists and empty lists gracefully. So if they pass in the empty list, you should do something, not just throw an error, but do something useful. If they pass you something that's not a list, because remember, when the user of your function passes in a value, they can pass in anything they want. So you may need to figure out some way to detect whether something's a list or not. There's a couple of ways to do that. You can do type X, and that gives you back list. So you can do a bit of research on how to use that. Another thing you could do is if something's not a list and you try to index into it, you get an error. It's a type error. So what you could do is catch that exception using try except, like I showed you in the last video, and do something. When I say, I just mean don't crash. That's what I mean. Don't let your program crash. Make sure that it either returns something that makes sense or prints an error to the user and aborts or something like that. There's lots of other list functions here, and I do suggest that you try them out. All right, this is the halfway point. I want to talk to you guys now about sets and dictionaries. So we're going to end up using sets and dictionaries a little bit in the course, so it's good to know about them. You have seen dictionaries before. I know you have. You've seen them in your data structures and algorithms class as hash tables. Java has a hash set and a hash table, I believe, type. Dictionary is another word for a hash table. It's also another word for associative array. So I know you've seen that in the PHP and JavaScript class. JavaScript has associative arrays, as does PHP. So another word for all of those things is dictionary. So dictionary, hash table, map is another one. Hash map. Oh, that's right. In Java, it's hash map, not hash table. So maps and also associative arrays and dictionaries are all the same thing. Let's start with dictionaries. So if I want to create a dictionary in JavaScript, I can do it like this with curly brackets. So that's an empty dictionary. So if I go type A, it's of class dict, D-I-C-T. And then if I can do this, Sam equals 1. Now if we look at A, it's got one non-integer key associated with the value 1. And then I can do Joe equals, I don't know, maybe we'll make this one a list. So you can store any type, you can mix and match types in here. And then you can access them like this. What's Sam? 1. What's Joe? That. What's something that's not in there? That's a key error. So you got to watch out for that. You can throw errors if the key value that you're giving it doesn't have a value associated with it. That's a basic dictionary. We'll deal with sets in a second. We'll come back and go over this with sets. So you can set a key, you can access a key. This is a much more useful way of accessing the value associated with a key than the one I just showed you. Because what you can do is you can say d.get Sam, and it will, sorry, not D, my dictionary is called A. A.get Sam will return the value associated with the key Sam. A.get something else. This is, you can see it looks like it's doing nothing here. Sorry, that's an unfortunate little quirk of the shell. It's actually returning a special value called null. So if I say x equals a.get FDSA, the point is it doesn't crash, but none never prints out. I think we can get around it like this: print x, that prints none, or type x, class type none. Okay, so what we can do is we can have a dictionary equals Sam 1 Joe hello, and then we can do this. We can say if d.get Sam is not equal to none, like that, print d.get Sam. Okay, so that should print out, oh yes, sorry, not equal to, that's not the double. Again, my Java is showing. So the last thing it prints out is a 1 there. If I change this to a different key, well, let's put an else in here. Print not found. And let's make this a little bit more useful. Let's say k equals input, enter a key. And then we'll use k as the key here. So, whoopsie, we're going to see if we can get the key. So enter a key, Sam. Oh, not found because I typed it with a capital S. So that's the not found path. Sam is a 1. So d.get is a little bit safer, a little bit easier to handle, maybe. You can also use the in operator. That returns true if the key is in D. So that's the other way you can do it, is you can check first. Say if k in D, print d.get k, or you can actually, now that we know that it's there, we can just do this. Else print not found. So there you go. There's two ways of doing it. Enter a key Sam. Both methods work. Enter a key, something that's not there. Both methods work again. So you can check ahead of time, or you can use the get operator. And there's a clear operator that clears out the dictionary. Okay. If you want to process a dictionary, you can do it with a for loop for key in D, like this. So you can go print. Let's do it up top here. Print dictionary for k in D, print k. So this is going to print out the keys, Sam, Joe, like that. If you wanted to print out the values, you could do it this way, dk. So let's run that again. Now it's printing out, this is printing out the full contents of the dictionary, going over the keys and showing each one in the dictionary. Enter a key, 5, not found. Okay, so this is an associative array, which has special syntax. It uses the curly brackets. You can build them up as you go, or you can create predefined dictionaries like this. What's the advantage of a dictionary? It's speed of lookup. So a dictionary is basically a hash table. So yeah, I can find out in constant time whether a certain item is in there or not. When we might end up using this is perhaps in our k-nearest neighbor algorithm, which will be the first algorithm we're looking at, where you have to vote. So you can ask somebody, you could create a little system here where you ask somebody, what name do you want to vote for? Check if the name's already in the dictionary. If it's not, create that dictionary entry and set it to 1. If it is already in the dictionary, add 1 to it. So you could have people vote by typing in names, and then at the end of that process, you would have a count of each item and the number of times it appeared there. That's very similar to what we'll do in nearest neighbor. Sometimes you just want to use a set. A set is also a hash table, but it only stores keys. It doesn't store values. So sets can be useful in the sense that a set is kind of like a list. It stores items, but it doesn't allow duplicate items. So if I go s equals new set, like that, I think it's a capital S. Pardon me. Let me go back and check that. Oh, I'm sorry. You know, you go a year between using Pythons, between iterations of a course, and you forget everything. We don't use the new keyword when we're creating objects in Python. So s equals set creates a set object, which prints out like that. And then we can add things to it just like a dictionary, but not quite in the same way. We go s.add Sam. Now we can see that it's got one item in it. It looks a bit like a dictionary. Add Joe. There it is. We can ask if, you know, is Sam in S? True. Is something else in S? False. So anytime you're building a list but you want to avoid duplicates, a set can be useful. Because if I add it again, if I add Joe again, it just, you know, doesn't fail or anything like that. It just does nothing because Joe is already there. So again, it's stored in a hash table, so lookup is quick and easy, and it doesn't store duplicates. So that's how you create the set. You can add and remove keys this way. Oh yes, to delete a key from a dictionary is the del operator, like that. So you can go del d Sam like that, and that will delete it. Is there not a remove? I'm doubting my own handout now. No, there's no remove method for a dictionary, but there is for set. So for set, it's, I wonder, can you del set? Why are these things so different? No, you can't. So to remove an item from D, it looks like you have to use del, and to remove an item from a set, you have to use the remove method. Okay. Yeah, and you can iterate over both dictionaries and sets in the same way. Just remember, when you're iterating over a dictionary, you have the key and you have the value that goes with it that you can look up using D. When you're iterating over a set, you only have the key. You can't do S, Sam, sorry, Joe, like that. You can't, it's not subscriptable. You can't use a subscript. All you can do is ask with the in operator if the key is in there or not. And you can iterate over it using 4k in S. Print S, that'll just print out Joe. Okay, that's it for the basics of sets and dictionaries. The next section here is on NumPy arrays. We're not going to get to that till next week. Again, I have a couple of exercises I would like you to try. So if you go into the exercises that are online, I'd like you to try both of these. And if you want to skip the list exercises and just use these, that's okay too, because these exercises are about lists as well. So the first one says, write a function that's given a list as an argument and returns a new version of the list with duplicate elements removed. The new list does not have to preserve the order of the elements from the first list. Use a set to accomplish this efficiently. So yeah, I'll give you some hints at the end so that you can pause if you don't want to hear the hints before you try it. Number 17 says, write a function that returns a dictionary containing a count of the occurrences of each element in a list. So you're going to pass in the list. This is going to be a lot like the voting that I told you about. And here you're going to use a dict object, a dictionary object. You'll iterate through the list. You'll store each element as a key in a dictionary object. And we have to check to see if it's already there. So as you're going through the list, you don't know what's going to be there ahead of time. So you're going to count occurrences. When would you do this? Well, you would do this if you were categorizing text. Machine learning algorithms that work with text usually work with word counts. So you would have to feed a document, turn a document into a list of words, feed that into a function like this, and then go through and count and build up a dictionary showing you how many times each word appears in the document. So all this stuff is, I've tried to make this stuff directly relevant to the kinds of things that we're going to do. Okay, so that's it. I'm going to give you a hint on the dictionary on number 16 in case you need it, but I'll say goodbye now, and if you want to stop the video and then get the hint later, you can pause it and then come back for the hint. Please try to get as much of this as you can looked at before our first class on Friday of this week, and we can go over some stuff and as you wish, as you guys see fit. I will come without an agenda, and it's up to you guys to ask me what you want me to do in that session. Okay, so if everything seems cool, maybe you don't even need to show up. I'd still like to see you there at least for a few minutes to say hi. But if you would like to go over this stuff in person, then drop in and ask me some questions. Okay. All right, so here's the hint for exercise 16. What you want to do here is just simply go through the list and add everything to a set. So create a new set, add all the items blindly into the set, then iterate through the set to put stuff back into a new list. So you go through the set and append all the items that are in the set back into a new list, and voila, you end up with a new version of the same list that you were given that does not contain any duplicates. It might not be in the same order that you entered it in, though, because sets kind of store things in their own order because of the hash table. So the returned list might come out in a different order than the original one. But that's basically what you have to do. All right, see you on Friday, I hope.